In this video, we're going to do a couple practice problems relating to the mean value theorem. First, using the mean value theorem, show that the graph of f of x equals x cubed minus x squared minus 4x plus 4 has a horizontal tangent line over the interval -2, 1. If we're going to use the mean value theorem, then this interval is probably going to be our a and b. So let's think about what the slope of the secant line is over that interval. That's going to be f of -2 minus f of 1 all over -2 minus 1. Or I should say f of b minus f of a, so I did that backwards. Let's do that again, sorry. F of 1 minus f of -2 all over 1 minus -2, b minus a. So plugging this into the function, we have f of 1 is going to be 1 cubed minus 1 squared minus 4 times 1 plus 4. And plugging in -2, we're going to have -2 cubed minus -2 squared minus 4 times -2 plus 4 all over 1 minus -2 is 3. So writing this all out, we have 1 cubed minus 1, 1 minus 1 minus 4 plus 4 minus -2 cubed, which is -8, minus -2 squared, which is minus 4, plus 8, plus 4, all over 3. We can see that everything is going to cancel out here. We're left with 0. So that means that the slope of the secant line is 0. So by the mean value theorem, there is a point C in the interval -2 to 1 such that f prime of C equals 0. Or we could say, or there is a horizontal tangent line at C. And that answers the question. We showed that there is a point where there's a horizontal tangent line. All right, second example, we have this word problem. A rock is dropped from a height of 100 feet, and its position in t seconds after it's dropped until it hits the ground is given by s of t equals -16t squared plus 100. Find the average velocity, we're going to call that v average, of the rock from when the rock is released to when the rock hits the ground. Find the time t when the instantaneous velocity of the rock is the same as the average velocity. So, first question is going to be, think about what time interval am I talking about? So when the rock is released, that's pretty clear that we're talking about t equals 0. But what about when the rock hits the ground? That's t equals, we don't really know, but we can find it by setting our position function equal to 0. So first thing is we're going to find t when the rock hits the ground. And we can do that by setting s of t equal to -16t squared plus 100 equal to 0. The position equals 0. So this is going to give us 100 equals 16t squared. Divide by 16. and that's going to give us 25 fourths. So that means t is going to be plus or minus 5 halves, the square root of 25 fourths. Note that we can't have a negative time, so we're just going to be using t equals 5 halves. All right, so that's the first part of the question down. We now have the time that we're talking about. All right, so next part of the question, find the average velocity on that time interval. We're going to find the average velocity on the interval 0 to 5 halves. And we can do that by just doing s of 5 halves minus f of 0 over 5 halves minus 0. That's going to be negative 16 5 halves squared plus 100, which we know is going to be 0, minus negative 16 0 squared plus 100, which should be 100. It's the top and the bottom of the ground, over 5 halves. That's the change in the position, which is 100, over, negative 100, because we're going down, over the time 5 halves, which would be negative 40, in this case, feet per second. Velocity can be negative, and since we are going down, we have negative velocity. All right, so next question. Find the time t when the instantaneous velocity of the rock is the same as the average velocity. And we know that this time exists because of the mean value theorem. We know that there is going to be a time when the instantaneous velocity is equal to the average velocity, so we can just find it. And we can do that by finding a formula for the instantaneous velocity, which is the derivative. That's going to be s prime of t. That's going to be negative 32t plus 0. And we can just set this equal to our velocity that we're looking for, negative 40. And we get t equals negative 40 over negative 32, which we can simplify to 5 fourths seconds. So we're going to reach an instantaneous velocity of negative 40 feet per second at 5 fourths seconds. When we think about a graph of this on the next page, we have a picture of our function, which is a parabola facing downward, negative 16t squared plus 100. And we found our average velocity was the slope of the secant line. And we have that the slope of that was going to be negative 40. And we found that there was a tangent line that was parallel to that secant line, and that occurred at 5 fourths. And we knew that was going to exist based on the mean value theorem.